this is procedure of sleep test. The test begins with entering the customer and vehicle detail into the system, such as username, car model, and registration date. After that, the vehicle was placed on the car wagon to measure its total weight, which was recorded as 1,192 kilograms. Once the weighing process was complete, the car was moved to the brake test position to prepare for the braking assessment. When the system showed that it was ready, the dynamic braking test was carried out. During this test, the braking force in Newton were displayed in real time using bar graph as the brake pedal was applied. At the end of the procedure, all the test data was recorded and saved in the system.
The vehicle, which is Nazakia, had been tested for set slip test, and we achieved the regular result. For the first point of the result, we can show for the brake performance. For the service brake efficiency, we measure the efficiency is 56%, which is successfully exceed the minimum requirement of 45%. So it shows that the main braking system is in good working order. For the parking brake, the efficiency is 18%, which is above the minimum of requirement of 16%. So we can confirm that the parking brake is functionally correct. And for the second point is individual brake analysis. So as you can see, for both left and right side show high and well balanced brake force, which is 3,920 Newton and 4,040 Newton. So the difference between them is within acceptable limit. So it shows that the front brake is stable and straight braking without pulling to one side. So rear brakes and for parking brake, the force are within the specific limit, so it can confirm the proper function. The parking brake is higher on the left side, but the overall efficiency it meet the standard. For the third point is weight and adherence. The axle weight have been measured. It shows that the load on the front axle, which is typical for front vehicle. So overall is the vehicle braking, which is Nazakia system, is efficiency and balance. The rear vehicle of Nazakia, the result was failed. It is because of the brake efficiency. For emergency brake efficiency is below the required minimum of 22.5%, which is 18.2. And then for the brake force and distribution, as you can see, the parking brake efficiency for isolated vehicle is only 12%, which is below than required of 15%. And then we move to the rear brake force. As you can see, for the left side is 2,750 Newton. For the right side is only 250 Newton. For, as you can see, it is big difference. So the brake difference is 91%, which is higher than the minimum limit of 30%. And then for the overall, the vehicle failed the inspection because of the poor emergency brake efficiency.
For discussion number 1, a large difference in brake force between the left and right wheel on the same axle caused the vehicle to pull strongly to one side during braking. This leads to directional instability and a high risk of losing control, particularly in an emergency spot. Puspacom standard. While regulation can vary slightly, commercial vehicle standard often specify that the brake imbalance must be less than 30%. For the service brake, your measure value for the hydraulic system front axle are 9%, while the rear axle is 12%, are well below the 30% limit, meaning the vehicle passed the stability check. For discussion number 2, if the adherence difference were more than 10%, it would indicate a significant issue with the vehicle weight distribution or suspension system on that axle. Unequal load distribution means the maximum braking effort achievable on the two sides is different, leading to the risk of one wheel locking up before the others, which will compromise stability and maximum efficiency.
Discussion number 3. Discuss brake force result based on rolling testing result. Front axle hydraulic brake imbalance is 9%. This is excellent and well within the 30% post-mortem limits. The front brake are balanced. Braking efficiency is 93%. This is very high efficiency, indicating the front brake system is performing exceptionally well relative to the axle weight. Rear axle hydraulic brake imbalance is 12%, also excellent and well within the 30% limits. The rear brake are balanced. Braking efficiency is 48%. This is good efficiency. The efficiency is naturally lower than the front axle because most braking force is designed to be on the front wheels. Braking brake mechanical braking efficiency is 80%. Parking brake efficiency is typically judged against a lower standard. 80% is deducted. Not that the 93% imbalance is common for parking brake that operates on only two wheels or have a differential and is generally not a failure criteria. Conclusion. Based on the analysis of side slip, adherence and roller brake tests performed on the vehicle, the experiment successfully diagnosed the braking system condition. The vehicle, with a record weight of 1,192 kg, demonstrates excellent and safe braking performance across all parameters measured. Specifically, the hydraulic service brake has high a minimal imbalance, recording 9% for the front axle and 12% for the rear axle, which is well below the crucial 30% maximum difference mandated by Malaysia's post-mortem regulation to ensure directional stability during braking. Furthermore, the system shows high overall brake efficiency with the front axle achieving 93% and the rear axle achieving 48%, and the mechanical parking brake also deliver an adequate efficiency of 80%. Therefore, the vehicle braking system is operating effectively, safely, and in full compliance with the primary safety standard tests.